Yeah, we're going to talk about business logic, okay? So my name is Filippo, as Ivana just said, and I work for a company called NetScout. Uh, Probably you don't know about us unless you work for an internet service provider. Then our products are definitely in your data centers, or if you're actually in a big corporation. And it's fine. I would like to just tell you one word about the team I'm working in, and it's called ACERT. And what we do, I work with the researcher and analysts to basically push to our products deployed globally, threat intelligence for DDoS mitigation. So this is what we do. It's pretty cool. I would love to talk with about honeypots and sinkhole and botnets, but we will not talk about this today, okay? We're going to talk about something else. And, okay, as you can see from the size of the logos, we are a big Python and C shop, okay? But we have one big project and few services written in Scala, and we work in Scala maybe more on the functional side, okay? And in production, for the last 2-3 years, we have some Haskell deployment, okay? And so this is enough about me. Let's talk about Happyland, right? What I mean with Happyland, so let's imagine a code base, your code base, any code base. In this code base, there is one part, okay? It could be just one Scala file. There's one part that is made of pure functions, okay? Where everything is beautiful. From A, you always go to a B, for every single A, and you go to the same B all the time without any side effects, right? In Happyland, basically we are mapping with F from A to B, okay? So in this place, this magical place that we may or may not have in our code bases, we can make example-based tests. It's very cool, like value in, value out. It's very easy to test our examples. And with mutation testing, we are super cool. We test our logic against, we test mutation of our logic against the example-based test we made. And even property-based testing, there are many patterns that works very well in Happyland, okay? So in Happyland, we have no needs for mocking objects. We agree on that, right? When we are in that place, we don't even talk about mocking objects. Now, let's start talking about everything else in the code base, okay? So first of all, I would like to bring to your attention this empirical study that basically analyzed a bunch of projects on GitHub for the use of mocking objects, okay? And they found out that one project out of 4 is basically using at least one framework, okay? Not for the whole code base, but for a portion of it, okay? And an interesting thing is that this research, basically, there's a different one, was looking for something on big open source project and a big enterprise project as well. They try to analyze how people is using mocking objects, okay? It's very hard to find papers like this. There are very few, but this one is super cool because after they categorize how people is using mocking object, they also survey but interviews the developer and team leads to understand which problem they had, why they use mock in that way, and other questions like that. So I'm mentioning this because I would like to talk about what we are mocking, okay? That's the question, before even thinking that that could be something that we can improve or not, okay? So if that's the question, basically they analyzed and categorized the way we are mocking, we as developers, we are mocking dependencies. And basically they say, oh, you know what? On the blue side, these are, for all the dependencies, the one that we're actually mocking. And on the other side, what we do not mock at all. Okay? And they found 3 different distributions. So for every categories of dependency, okay? So I was wondering if you can guess which kind of dependencies, which category of dependencies are actually falling into the first distribution. Do you have any guess? Something, okay, I cannot see you at all. It's very dark here, but it's external dependencies. I mean, you could have guessed that, right? So 2 times over 3, basically, we as developer, we are mocking those dependencies. And by the way, when you see web services, the paper is mentioning everything over HTTP. So it could be your code hitting an internal services, a bunch of internal services, or going out in the internet. So this is interesting because it means that it's something that we mock a lot. And the reason is because complex setup and slowness, of course, something external. Now, can you guess what we mock about once, every three times we have a dependency that we want to mock? Crazy. I wouldn't expect that. It's business logic. I thought it was the third one, actually. But anyway, and this is the reason, after all the surveys, people mock business logic because it's too complex, okay? So we get to write our test code, and we find out, shit, we need mocks. There's no way to write test code without mocks, okay? And then there is other things like people is mocking Java libraries and things like that. So this is the question. Why? Why sometimes I have this urge? Why I need to bring into my toolbox such a powerful tool? Because mocking objects like the framework out there are very powerful and sophisticated. Why I need those, like this nuke option, okay? Quick semantic detour. Keep using terms probably, there's no a common way to talk about it. So this is the real term. When every time I say mocking object, actually I mean test double according to extreme programming and Martin Fowler. And by the way, Wikipedia also say the same thing, but probably you notice as well, everybody is saying the same thing in very different ways. And today we're just going to talk about three types of mocking objects. So every time I say stub, I specifically talk about that mocking, that mocking object that basically we program to give canned answers, okay? So it's a mocking object that we normally use to set up our test scenario. The second type of mocking object, when I say mock, without saying mocking object, I mean the one that we normally use to test the expectations, okay? Those guys are the one that you program to basically expect how many times that specific method get called, and sometimes even with what parameters. And the third one we want to look at the end of this presentation is about fakes. And fakes are basically a minimal implementation that fulfill an abstraction, an API, whatever, but it's not like a production thing. So for instance, if your service is spread across like a cluster of thousands of nodes, well, when you do integration testing, you would prefer maybe to use something in memory. And we have a quick look on the users later on this one. Anyway, long story short, every time I say mocking object, I mean those things that we use instead of the real feature code, okay? Okay, enough talking about theory. Let's look at some Scala code, okay? Let's look at some examples. Okay, the reason, according to the definition, the reason why we use stubs is to control the behavior. So we are in front of our IDE, we would like to write test code, but now we need to control our, the code that we would like to test. Okay, this is when stubs, they get into the picture. So let's consider this potato service. And the potato service gets a config, okay? And this kind of, dependency injection kind of thing. But the config, all it needs are those two values, the variety and the numbers of, the number of potatoes that we want to use to make the potato salad, okay? Now, there's nothing wrong with this code, but the config, it's actually made of 92 moving parts, okay? It's not just those two things. So when it comes to testing, we cannot just instantiate the config because there are too many things to think about it. So all we do is like, oh, I know how to do it. I prepare a stub with canned answers with exactly what I want to hear. So I'm programming the stub to give me the lie I want to hear to make my test, okay? And then what we do, we set up the service, we run it, example test base, done, and we call it a day. There is nothing wrong, this is fine. But we can agree that having 92 moving parts in config, it's something like this, right? So we only need two things across all this stuff, right? So if you're thinking about the abstraction, definition of abstraction, it's basically we need to know just a little that we need for the stuff we have to do. So to be honest, I really prefer to have two values. So if my potato service just needs those two values, I prefer to write this way. It's one way to do it, okay? It's not the way to do it. So, but when we do something like that, then we just need to wire that up to the current application, to the current program, like this way. We just get our real config, and we just get what we need. So it's not a big deal, to unplug this and refactor that way. This way, we're going to remove the fat dependency from the service. And the test, okay, could become something like this, 2 lines. We set up the service with values, and then we basically do our salad, and we check that the salad is exactly what we're expecting. Okay? So when it's value in, value out, life is way, way easier, right? That was a very simple example. Let's see something different, and not just stub are needed for our test, but also mocks. So according to the definition from the Extreme Programming Manual, we need mocks as an observation point. Okay? So let's say you have something that creates side effects. You want to observe them, okay? But to observe them, you can capture them with a mock. So I don't know about you guys, but when I change teams in my company, sometimes you get like people straight from Java, like from many years of Java, like me, I was like years ago. And when you're in Java land, you use usually there's a tell, don't ask kind of pattern to do things. So as you can see here, there are verbs. So what you're doing with this kind of approach to the design of your application, you're actually you're encapsulating the state within objects. I don't know if you're familiar with it, but it's very simple. But what you get back is you have verbs to the things you have to do. So I want to remove a bunch of coins from my wallet to insert into the vending machine to get my can. Okay? And when somebody join your Scala team, is gonna start writing maybe things like this, and it's fine. I mean, is following that pattern. Okay, I know some people is maybe coughing because there's units everywhere. Okay, it's fine. I mean, this is part of the pattern. Okay. Now, how can we test this? Well, as I said, we're gonna use stubs. So we have a wallet stub, and we're gonna have, because we have to set the state. We cannot set the state of the wallet because there was nothing, about the state of the wallet. We need to basically mock using a stub the remove coin, and same thing with the vending machine. We're gonna stub the calls that we need. So the stub will help us setting up the scene for our test. And then here on the right-hand side, we have the mock part. I'm expecting once and only one time those calls. If something goes, even slightly far from what I set the mock to do, my test suite is gonna scream, okay? And that's it. I'm gonna run the thing, buy a drink, test passes. Now, I said we are, with the tell, don't ask, we are encapsulating the state within the thing. But what about if we use a different approach? If we don't care about encapsulating the state within the object, well, we actually try to be explicit, okay? So instead of having mutability within this objects, this mesh of objects, why don't we just be immutable? So when you buy a drink, you just don't get the drink. You get the customer and the vending machine, right? This is, this is one way to do it, of course. So what we're doing here, we're making the state explicit. These guys now are stateless, okay? These things are pure, and the thing is that immutability is setting us free from the isolation that tell, don't ask is actually drive our design to, okay? So this, again, it's one way to do it, and how the test would look like. The test, it's very simple. We set a wallet, because now we can set the wallet. We set a customer, the vending machine, and then when we buy a drink, we get a poor customer with 3 less coins. And then, we check that if we have the can at the end, and everybody's happy. Test passes. Again, I'm not saying you have to solve this problem this way. And by the way, you could argue that, and I heard this in the past, when you convert the code to something like this, somebody could argue saying, you know what? This is not a unit test anymore. When I had mocks, this is now an integration test. What's happened here? Is this an integration test? 1 second. Is everything all right? It's bad. Yeah, is it an integration test or not? I don't know, because personally, I do not believe this is an integration test. And I'll tell you why. Because when you have functions, like pure functions. When I have two functions, I combine them, I get a function. And when I get like 100 functions and I combine them, I still get a function. So we can argue about that. But long story short, these kind of changes we can make in our implementations we can agree that these are like low-hanging fruits. If you consider FP like a tall tree, these are very low-hanging fruits, okay? This is kind of a warm-up. To be honest, I felt in my past few years that the biggest challenge, especially with Scala, is working with essential effects, where everybody has an opinion on how to control them, right? So for that, let's take a look at another example, okay? So we try to create an indicator. An indicator is basically an indicator of compromise. It's basically, I don't know if you're familiar with malware. So let's imagine that somebody is trying to create a botnet and is trying to attack your light bulbs in the kitchen or the fridge or the washing machine. So you have different malware. It's the same malware with different binaries because a light bulb has a different ARM architecture, okay? So what you do normally when you specify an indicator of compromise, you have multiple signature of those binaries, okay? So let's say this function could be something like get the malware indicator. That what it does, you fetch the malware from one system, and then you check if you have samples from maybe another system on a different company as well, and then if that is the case, you create an indicator and you pass that back to the user, okay? This is like a simple example that actually show you that we have two different like fetch malware and fetch sample hashes, two different methods there. They have an effect, okay? Now, there is nothing wrong, right, with this code. This code actually works, but nowadays, and if you show this code to maybe your peers in a code review, sometimes you get banned. Like, what are you doing? Like, why are you going straight and use directly, effects without even, try to controlling them, right? So there was like a slide here. Here we go. With the tests, that what we do here is something very simple. We are in the category of external dependencies. So we create a stub, and this is the lie we want to hear, okay? Because this is the way we want to set up the test, and then we expect those two things to get called only once. We set up the test, we run it, and we check that everything is as expected, okay? Now, we do that because we don't want to hit the real thing, of course. But one thing I'd like to point it out is that get malware indicator, when we call that function, the effect is not, we're not controlling it. Come on, the effect is buried deeper, like few level deep down. So it's the effect is not controlling anyway, right? So the thing is, when we call that get malware indicator, it's already too late, okay? The effect is already gone, so we're not taming it. So in other words, and that's the point I'm trying to make about this implementation, is that logic and effect are entangled. Even John earlier on, this morning, mentioned something about entanglement. That's exactly it. Logic and effects are entangled here. So now we need to have a quick talk about, does it make sense to have a program with only logic and no effects? Of course not. It's like a warming box. Or vice versa. Can we have a program with just effects with no logic? Of course not. Because there's always a combination. But when it comes to testing, and this is what we're talking about here, we can do something, it's naturally easier, if you ask me, to test logic, right? And it's slightly harder to test effects. There's more machinery involved. Now, if I'm going to add another dimension, and I'm looking for the number of test cases that will make me comfortable, to have in my test suite for logic, I would say I want to have many test cases, right? So I would put logic there. But when it comes to pure effects, forget about pure, let's say effects that I'm controlling, I want to have fewer tests, but very hard. Hard in the sense of there's a lot of work, a lot of machinery involved. This is fine, but this is not the real world, because from time to time, because these guys are orthogonal, we get the worst of both worlds, okay? And we are in that quadrant. Fine. It's not a big problem. We have the tools, and we use mocking. even if we don't like it sometimes, but when we have to test logic and effects together with mocking object, that's possible, okay? And the thing is, that legitimizes your design means that, sometimes you don't have the motivation to go back to your design and try to remove the need of the mock or try to separate logic and effects. And the other thing that somebody is mentioning, like years ago, is that you're creating integration test and making that possible as unit tests, okay? And I tell you what, I justify this, I totally understand that because I've been there. I've been there. And I don't know if you're familiar with this expression. With fog of war, I mean, every day we are in a sprint, in a development sprint, and we are focusing not on writing code. We are focusing on delivering features, right? And sometimes when you have a correct code and you want to deliver the feature, and when you have machinery that lets you deliver the feature, it's fine, use mock. You know what I mean? So I completely understand and I justify that. But there's a cost. There's always a cost that it's not that clear. Same research explained that when you add a mock, and that happens at the beginning of the, when you write a test code the first time, the mock stays there, okay? Why that scares me, and if you use mocking objects in your career, anytime in your career, you know exactly what that means. The same research found out that the mocking objects between commits are changing often. Because even if you touch code not related to the mock, just outside, you have to update the mock. And you know exactly what I'm talking about when I'm saying this. So maintaining the mocks is hard. Well, thank you. They find out on a paper, but I'm telling you, I already realized that, So, and yes, mocks increase the coupling between test and code, as we did just earlier on with our example. I think we could agree in that. So let's try to separate logic and effect, right? Now, it's not that easy, not because we do not have the technicality to do it, because we don't have the theory behind, but because everybody has a different idea on how to do that, right? There's different programming styles, and every team is different, and every teammate is different, right? So I hear many times, do not commit too early, right? Do not commit too early, and the safety functor is going to come to us soon, right? Because we're going to abstract. And when we hear this kind of stuff on Twitter or from our teammates, what we're going to do, we're going to abstract everywhere, even if we don't need it, right? Look, I've been there. I've been there. This is so funny because it's so true. I was the one that entangled your code base with free monad when the boilerplate was, nobody was understanding that in the team. I've been there. And many of you, I'm pretty sure you've been there too. You over-engineer maybe, or you engineered right, but was not the right thing for that specific solution that you were looking for, or for that team, okay? That's fine. But my point here is that there's no silver bullet. Okay, I haven't found a silver bullet yet, okay? But what I know for sure is that Scala developers, me included, they're very good on applying functional programming in the small. But when it comes to the large, this is where we spend more time discussing than actually writing code, right? And there's always trade-offs. I mentioned trade-offs because there's a cost of abstraction. Not just the noise of the boilerplate, like your interpreter, your algebra, sometimes that you add for reasons, but also because we should follow. I strongly believe that we should follow the rule of least power. Okay, so it depends on the situation. But I'm telling you one thing that I personally do all the time. Every time an abstraction is going to bring in the fear in me to refactor, well, it's time to reconsider the abstraction, okay? I want to be free to refactor anytime. And guys, I'm abstracting a lot, so I'm not a saint, okay? I'm over-engineering a lot, okay? That is why I would like to show you one approach. There are many approaches, but there's one that I've seen in the Python world a few years ago. It's called functional core imperative shell. And Gary is the guy that bring up this thing, is mentioning the fact that there is a big circle. Okay, this is the imperative shell. And that is wrapping all the business core, okay, the business logic at the core. And you try to make business logic as pure as possible. not just as pure as possible, that's a subtle detail, also with as much logic as possible. So we are trying here to move all the ifs, all the logic from the outer circle to the inner tiny little circles, okay? Okay, fine. To me, it sounds like happy land, okay, inside this circle. Now, if we do that, oh, by the way, maybe you heard, if you're coming from object-oriented world, you heard that called as clean architecture, I don't know, or this is a very hexagonal architecture is another way to call it, with primary adapter and secondary adapter, or yeah, the onion architecture, if you did some Haskell, with all the semantic layers, a communication between layers. They're all very similar, and what they have in common is boundaries. They really, really try to make boundaries between facts and your business logic. This is what they try to do, to minimize all the ifs, okay, all the logic and in the effect part. So what that means, it means that if we remove the if, or if we try to minimize those ifs, all we have there is just a trigger, okay? And this is one point I'm trying to make, that when that part is so easy, okay, first of all, Alessandro knows I'm really against the ID monad for some reason. So if this is a trigger, I don't even go down the path to use ID monad to test it, right? I'm trying to go to different paths that we're going to see in a second. But that's the point, is because the interactive, the imperative shell is basically very thin, and is just a trigger to the effect. That's why, here we go, I prefer to do integration tests there. I know it's very unpopular. I know that. But the point is, I trust my integration tests, a few of them, to test, the outer circle. And I'm using many unit tests, as we discussed, for the pure part. Fast unit test. Okay, let's have a look at our code and how can we move, change our design to a possible way to change our design to functional call. So this is the sample available. It's a pure function, as you can tell. And yeah, what we're trying to do is to create a shell where we push all the effects outside. Okay, as I mentioned earlier on, I'm trying to gauge the abstraction. So here I'm using a task. Think about like IO monad. Could be anything, Monix, scala-italy, whatever. The point is, fetch malware and fetch sample hashes as well, they are describing now an effect. They're not performing the effect. Because, of course, I'm doing this to try to detonate those effects as late as possible. I'm trying to push out, okay, those effects, simply describing them, because I don't want to get blindsided, okay? If I make effects as a first-class citizens, I try to, control them this way. And before you get crazy at me, because I didn't use F or I didn't abstract over that, it's because sometimes I feel like I fall into the complexity trap. Complexity trap meaning that if I'm trying to over-abstract for simple examples like this one, it's like, do you remember when you were abstracting over your SQL engine because maybe you don't want to commit in this very moment to Postgres or MySQL? Well, this is kind of the same thing. You can do it, there's nothing wrong. But sometimes, in many, many situations, I prefer to choose directly an effect type, okay, to work on. Again, it's a matter of taste. Everybody is different. And honestly, I truly wish, this is Haskell, Simon, Peter, and John, I truly wish my Scala compiler would actually know about effects, okay? So that way, we can actually work better on trying to don't pollute, effectful and not effectful code. Speaking of which, there's an ongoing discussion in the Scala community about bringing pure and impure tags, like tailrack, okay? Same thing, but for pure, in order to tag, like tag methods function, if they're pure or not. I'm honestly really, really interested in the impure annotation because I dream about a Scala where the Scala standard library is all tagged when everything is impure, So with a like a compiler warning or something, you will know when you have to expect an effect from a call. You know what I mean? Try to control those effects. But the other thing is, if you're working on a library for your systems or a public library, you can actually use a compiler to force you with errors to actually add these tags. That would be nice. But as I mentioned, I'm using a lot integration tests for testing that, that outside circle, okay, of the imperative shell. And I would like to bring to your attention, there are many ways, okay, but I normally categorize in two. I normally do integration tests, all handled by the CI, where, of course, every single test, they can work in parallel as well, but I let the CI control it, or I can do something more granular with test container. Test container can use Docker Compose, of course, or simply spin up and down the Docker container we want. These are two techniques I'm using for testing, effects. And I would like to bring to your attention that because when it comes to effect, as I said, I prefer to test that thin layer with something like this instead of ID mono. Now, okay, if you spoke with me over the last couple of months, I can't stop talking about that, right? I always talk about state-based property testing because I really like the idea to basically, when you have like a complex system, you can actually write a model. And you can run this kind of test if, oh, by the way, you must have observable effects. So if you have observable effects, this is something I really suggest you to try it out. Because you can describe the model, and then you can test against that model and against the real thing, okay? I know, enough about integration tests. I would like to mention something very important about mocking object, that we shouldn't throw mocking object with the bathwater, okay? Because there are scenarios that, if I look back, the last decade, I think mock objects have been very helpful to me. And, I think there are good parts, okay, on mocking object. And to be honest, if I'm going to use an example of JavaScript, that book about the mocking object good parts really depends on every single one of us. So for me, it's whatever number of pages, but depending on the people, it's just maybe the cover or is as thick as the other one. It doesn't really matter. I would like to share with you what I found very useful in my experience, okay? So for instance, fakes. I don't know if you guys have to do regression. Sometimes you have maybe to do regression on performance. So you want to make sure that some business logic, they keep performing even, commit after commit to certain quality level, okay? Using fakes, you can actually have predictability on your dependencies, and you can actually make sure in your CI that your tests are running, are not flaky first, and also are running within those parameters. Another thing is when you have effects that, probably management will be not very happy to run every, at every push. Or other things that I really like mock about, and to be honest, that's probably the number one, is when you have strange bugs, like hard bugs to find that you can actually describe with mocking objects. You make your failing test, and then you change your code in order to, to fix the test. And that's something that really for me is the number one thing, number one selling point for mocking objects. And of course, when you have a code base with no tests, because that happens, okay? That's a way to start, and also disposable test. I don't know if you guys do TDD, but it's kind of needed, having mocking objects. Okay, again, probably somebody has the list is way more for them, or maybe it's shorter. But I would like to find like a common point where we all agree that when choosing between like no mock at all, or maybe one mock, I would like to agree that probably we should try without any mock at all, okay? So it does, sometimes people take this religiously, like, oh yeah, I'm a mocking guy or stuff like that. No, if we agree on that, it's a good starting point for a conversation, okay? And another thing that's very important is probably you already noticed that in this talk, I'm definitely, there's this bias. So I showed you examples, I showed you papers, everything towards what I believe is actually the way to deal with mocking objects. But honestly, I noticed online there are fights, there are discussions, eternal discussions. So please, take what I'm saying with a grain of salt, okay? So these are more or less my opinion. And this talk was tailored for a beginner audience, but I really hope you found one or two interesting things. And I thank you for your attention. Thanks. Thank you. There's time for questions? Oh, shoot. No, it's a very controversial topic, so let's be kind, okay, each other.
Questions?
Awesome.
No questions.
Thank you very much, guys. Thank you.
Oh,
Oh, no, there's a question.
Last minute question.
No, it's okay, it's okay. Sorry?
Hi. What's your opinion on working with the TDD approach?
I didn't hear anything, sorry.
What do you think about TDD approach? Because
What do I think about it?
because when we work with TDD, we do more unit test than integration test.
Okay, what do I think about TDD when we do more unit tests than integration tests? Okay, let's step back on the amount of tests. I'll tell you again, an opinion. So when I look at unit tests, I always look at the ROI, like return on investment. And I'm a big fan of deleting tests. I kid you not, I like to delete even other people's tests that don't make sense in my code base. Not to make the test faster, because unit tests are blazing fast. Sometimes even less than 1 millisecond, actually often less than 1 millisecond. TDD makes more unit tests, yes. But many times I remove unit tests I made with mocking objects. Because after I have the whole thing and I trust the integration test, I take that off. I'm not saying this is the way to do it, but this is one way I do it. Okay, again, I'm a big fan of integration tests, so because they save me many times. But this is one way I do it. So most of the time, when I do TDD, and I don't do TDD often, but when I do it, I remove the unit test that I had mocked. Yeah, I don't know what do you do? Do something like this? You want to share?
I am I do opposite way. I prefer.
Here we go.
So sorry.
Oh, hold on. That's brilliant. Do you agree that if we can use 0 mock or 1 mock, we should go with 0? Yeah. See, it's a common point. At least we start from there. Awesome. Thank you. Thank you for the question.
Any other question? Doesn't look like it. Thank you, Filippo.
Thank you for your time,
Thank
guys.
you.